Here is another example where we're asked to solve the system of equations graphically. The system is y equals 3x plus 6 and 9x minus 3y equals negative 18. The first step is to make sure both equations are written in slope-intercept form. The first equation, y equals 3x plus 6, is written in slope-intercept form already. There's no work to be done. The y is by itself in the equation. But 9x minus 3y equals negative 18 needs to be rewritten. It needs to have y solved for in that equation. So the first thing we'll do is subtract 9x from both sides of the equation. That gives us negative 3y equals negative 9x minus 18. Then we'll divide both sides by negative 3, which gives the equation y equals 3x plus 6. Now, the second step graphically, or solving by graphing, is to then look at your two equations and plot the y-intercept and use the slope to plot a second or third or however many points you need to see the line. So we can see the first line's equation was y equals 3x plus 6. So it's easy to see the y-intercept is 6 from the value of b. So we're starting at 0, 6 on the coordinate plane. And then the slope is 3 from the coefficient of x. So we're going up 3, right 1, up 3, right 1 from that y-intercept, or down 3, left 1. Now the second line is also y equals 3x plus 6. So the y-intercept is 0, 6 from the value of b, and the slope is 3 from the coefficient of x. So from 0, 6, we're also going up 3, right 1, or down 3, left 1. And we can see that plotting these two lines on the graph, looking at the same y-intercept and same slope, we see that these two lines are the same. You've graphed them on top of each other. So for step 3, when we're locating the point of intersection and checking our work, we can't find just one point of intersection because, again, these are the same two lines. They're intersecting everywhere. They're intersecting in an infinite amount of points. So that means our solution to this equation is that there are infinite solutions. When you graph a system and the two equations graph the same line, or the same line right on top of it, another line, they're the same line. The solution is that there's infinite solutions. Now let's take a look at this example. Again, it's asking us to solve the system of equations graphically. And we have the two equations, 4x minus 2y equals 10 and 8x minus 4y equals 12. Neither of these equations are written in slope-intercept form. So step number 1 is to write them in slope-intercept form by solving for y. The first equation, 4x minus 2y equals 10, we have to first subtract 4x from both sides of the equation, and then divide both sides of the equation by negative 2 to get y equals 2x minus 5. The second equation, 8x minus 4y equals 12, we first have to subtract 8x from both sides of the equation, and then divide both sides of the equation by negative 4, which gives us the equation y equals 2x minus 3. Now that both equations are written in slope-intercept form, we can easily see the y-intercept and slope and use it to plot both lines. The first line has a y-intercept of 0, negative 5 from the constant and a slope of 2 from the coefficient. So beginning at 0, negative 5, and then using the slope up to right 1, we get our first line. And then the second line, we get a y-intercept of 0, negative 3 from the y-intercept from the constant in the equation. And the coefficient of 2 tells us we have a slope of 2. So the second line is graphed by graphing the y-intercept of 0, negative 3, and using a slope of up to right 1 to get the second line. Now you can see graphically that these are parallel lines. They have the same slope with different y-intercepts. So if we're trying to locate the point of intersection to check our work, we can't find a point of intersection. These lines are parallel, they have the same slope, they're never going to intersect, so our solution is no solution. These two examples were special cases of systems that when you graph them, you're either going to get the same line or two lines graphed on top of each other, meaning your solution is infinitely many solutions, or you're going to get parallel lines like you see here, meaning that you have no solution. So you just have to be on the lookout for these special cases when graphing, because you're not going to have your standard point of intersection as your solution.